Good morning to this is Shobha, Physics PGT from KGBV Setanagaram. Now I would like to explain about alternating current part 2. So, in this, already explained in previous class, AC voltage is applied to an resistor. So, now I would like to explain about AC voltage is applied for an inductor. So, what is the current? When an AC voltage is applied to an inductor, what is the current? Now we have to learn. So, here, see once AC voltage. This is the AC voltage applied to an inductor. This is the symbol of inductor. So this is the positive terminal of the inductor and this is the negative terminal of the inductor, and this is positive and this is negative. So this is AC supply, AC voltage supply. So AC source. So this is the direction of the current. Suppose this is the direction of the current. So according to Kirchhoff voltage law, we know that same Kirchhoff voltage law explain about the directions. Suppose if the direction is same as the current direction, then it is negative. Suppose if the direction is opposite to that direction of the current, then it is taken as positive. So this is positive and this is negative. So this is the direction of the current. Whenever we applied AC voltage to this circuit, then what will happen? The current is passes through the inductor. So whenever the current is passes through the inductor, then the flux is varies. Magnetic field is produced and the flux is varies. Due to this flux, induced EMF is generated in that circuit. So here, induced EMF is generated in that circuit in this inductor. So what is the, whenever AC voltage is applied to that inductor. So then what will happen here? Whenever the flux is, the current is passes through the inductor, the flux is, the magnetic field is varies. Due to that varying of magnetic field, flux is also varies. So from that, induced EMF is generated in that inductor. So what is the current passes through the inductor? So we have to calculate. So AC supplied, AC voltage V is equals to, already we know that Vm sin omega t. Vm sin omega t. So here, this is the AC supplied. AC voltage is supplied to an inductor. And this is an inductor. So this is nothing but self-induction. So induced EMF is nothing but L into di by dt minus L into di by dt. So from that, V minus, here what is that potential drop? That is nothing but VL. VL is equals to 0. So here what is V? V is nothing but AC voltage, that is Vm sin omega t minus VL is equals to 0. From this, Vm sin omega t is equals to VL. So what is VL? VL is nothing but induced EMF, so that is equals to minus L into di by dt. So from that, Vm sin omega t is equals to L into di by dt. So here this negative sign represents the direction, opposite direction. Suppose we have to take a magnitude. So what is the induced EMF? So that is magnitude. So that's why we have to neglect that negative sign. So from that equation, so what is that? Vm sin omega t is equals to L into di by dt. According to cross multiplication, from that Vm sin omega t dt is equals to L into di. So here L into di is equals to Vm sin omega t dt. So we have to apply integration. Then what will happen? Vm sin omega t dt by L is equals to di. So we have to apply integration on both sides. Then what will happen? Vm by L is nothing but constant. Vm by L integral sin omega t dt, that equals to integral di. So here from this Vm by L sin omega t. So what is the integral of sin omega t dt means? Sin omega t dt is nothing but minus cos omega t, and what is the integration of sin omega t dt? Sin omega t is nothing but cos omega t. From that omega t, omega, that equals to I. So here this can be written as Vm by L omega minus of cos omega t, that equals to I. So here minus cos omega t. So here see once the voltage is in sine. So V is equals to Vm sin omega t. So here the current is nothing but Vm by L omega minus cos omega t. Suppose we have to convert cos omega t minus cos omega t in sin omega t. So then what will happen means, so here this can be written as in terms of sine. So sin 90 minus theta. Sin 90 minus theta is nothing but cos theta. So sin theta minus 90, that can be written as minus cos theta. Sin theta minus 90 is nothing but minus cos theta. So in place of minus cos omega t, so what we have to substitute? Vm by L omega sin omega t minus pi by 2. This can be written as sin omega t minus pi by 2. So that equals to I. That equals to I. So from that Vm by L omega sin omega t minus pi by 2, that equals to I. So here L omega can be written as XL. So XL, it is represented by XL. So Vm by XL is XL into sin omega t minus pi by 2, that equals to I. So where XL is nothing but inductive reactance. Inductive reactance means this is a kind of resistance which is offered by the inductor. So that is nothing but XL. So it is represented by XL. So this is also a resistance. So this is also a resistor. This is the resistance which is offered by the inductor. It is nothing but resistor. So that's why the Vm by XL can be written as Im sin omega t minus pi by 2 is equals to I. So this is the maximum current. So here, this is the current when an AC voltage is applied for an inductor. So what is the current? Im sin omega t minus pi by 2. So here Vm is nothing but maximum voltage. Vm is nothing but maximum voltage, and XL can be written as XL is nothing but XL is equals to inductive reactance. Inductive reactance. Inductive reactance, and this is a kind of resistance which is offered by the inductor. So that is nothing but XL is equals to L omega. XL is equals to L omega. So here the current, already we know that whenever AC voltage is applied for a resistor, whenever AC voltage is applied for a resistor, then what will happen? Then the voltage is Vm sin omega t and the current is also Im sin omega t. Whenever we place a resistor, so then what will happen? There is no phase change. So why? Because there is a V is equals to Vm sin omega t and I is equals to Im sin omega t. The curve is overlap each other, so there is no phase change between the voltage and the current. But in case of inductor, what will happen means, here the voltage is Vm sin omega t and the current is Im sin omega t minus pi by 2. Minus pi by 2 means here what will happen? The current lags. Here the current lags by the phase reference is pi by 2. By pi by 2 radians. So here the current lags. In case of resistor, there is no phase change. In case of resistor, there is no phase change. Why? Because here in that V is equals to Vm sin omega t and current I is equals to Im sin omega t. So there is no phase change. In case of inductor, what is voltage? Voltage is nothing but Vm sin omega t and the current is nothing but Im sin omega t minus pi by 2. It represents that, it tells us about the current lags by pi by 2 radians when an inductor is applied for a AC voltage. So here, when the AC voltage is applied for an inductor, then what will happen? V is equals to AC. This is AC voltage. V is equals to Vm sin omega t. This is the positive terminal and this is the negative terminal. And the direction of the current is in this direction. So here, according to Kirchhoff voltage law, if the direction is same as the direction of the current, then what will happen? Then it will be taken as negative and opposite to the direction of the current, it will be taken as positive. So here, whenever the AC voltage is applied to an inductor, then what will happen? The current is passes through the inductor. Whenever the current is passes through the inductor, magnetic field is varies, then the flux is also varies. Due to the varying flux, induced EMF is generated in the inductor. So then what will happen? This is nothing but self-induction. So what is the induced EMF? Minus L into di by dt. So here the voltage is, here what will happen? This is the AC voltage V minus VL is equals to 0. So V minus VL is equals to 0. From this equation, V means Vm sin omega t minus VL equals to 0. Vm sin omega t equals to VL. So what is VL? VL is nothing but L into di by dt. Potential drop across the inductor. VL L into di by dt. So here this negative sign represents the direction. We have to take a magnitude. So from that it will be positive. Vm sin omega t is equals to L into di by dt. So from this equation, Vm sin omega t cross multiplication, we have to do the cross multiplication. Vm sin equals to di. So we have to apply the integration on both sides. Then what will happen? Vm by L integral sin omega t dt equals to integral di. So here Vm by L sin omega t dt. What is the integral of sin omega t dt? Minus cos omega t in omega t. So what is that omega t? Omega t is nothing but omega by omega. So minus cos omega t by omega is equals to derivative integral get cancelled, then it equals to I. So Vm by L omega minus cos omega t equals to I. So Vm by L omega. So here this is minus cos omega t. So here the voltage is in sin omega t. So Vm sin omega t. So we have to change minus cos omega t into sin. Then what will happen is, see once here sin 90 minus theta is nothing but cos theta. Sin theta minus 90 is nothing but minus cos theta. So here this can be written as sin theta minus 90. Theta is nothing but omega t. Sin omega t minus pi by 2. So that equals to I. So Vm by L omega sin omega t minus pi by 2 is equals to I. So where here L omega is nothing but XL. L omega is nothing but XL. So where XL is known as inductive reactance. So this is an offered resistance offered by the So XL is nothing but inductive reactance. The resistance offered by the inductor. So this is known as the resistance offered by the inductor. So that side is known as inductive reactance. XL is equals to L omega. So here Im sin omega t minus pi by 2 is equals to Im. So this is the maximum current. So what is the voltage? Voltage is nothing but Vm sin omega t, maximum voltage Vm sin omega t, and the current Im sin omega t minus pi by 2. Means here what will happen means the current lags by pi by 2 radians when an AC voltage is applied to an inductor. So from this equation we have to conclude that the current lags pi by 2 radians. The current lags pi by 2 radians when an inductor is when an AC voltage is applied to an inductor. So the next one is AC voltage is applied to a capacitor. So this is AC voltage and this is the capacitor. So this is the positive terminal and negative terminal, positive and negative, and this is the direction of the current. So here voltage is V is equals to Vm sin omega t. Vm sin omega t, and here the capacitor So the next one is AC voltage is applied to a capacitor. So this is the AC voltage Vm sin omega t. V is equals to Vm sin omega t. So here the potential drop across the capacitor. We know that Q is equals to CV. From that V is equals to Q by C. V is equals to Q by C. So here from this equation V is nothing but AC voltage. Here the potential across the capacitor. So here the potential drop across the capacitor is VC. So V minus VC is equals to 0. From this, what is V? V is nothing but Vm sin omega t. 0. So Vm sin omega t is equals to Vc. From this equation, Vm sin omega t equals to Vc. So what is Vc? Vm sin omega t is equals to, in place of Vc, we have to substitute Q by C. So Vm, according to cross multiplication, Vmc sin omega t is equals to Q. So here, this is Q, charge, Vmc sin omega t. We want to calculate the current. So here, dq by dt. So we have to differentiate with respect to time, then we will get the current. So dq by dt is equals to, dq by dt is equals to d by dt of Vmc sin omega t. Vmc sin, Vm into c sin omega t. So here dq by dt, dq by dt is nothing but current. So what is current? What is current? The rate of flow of charge is nothing but current. So that from that, dq by dt is equals to d by dt Vm into c sin omega t. So here, from this equation, dq by dt is nothing but I. I is equals to, here, dq by dt is nothing but instantaneous current. So, I is equals to d by dt, Vmc is constant and d by dt of, it varies with respect to time, sin omega t. Sin omega t, then I is equals to Vmc. What is the differentiation of sin omega t? Sin omega t is nothing but cos omega t in omega t omega. Suppose in case of integral it will be in denominator, in case of differentiate it will be multiple. So from this equation, I is equals to Vmc Vm omega c cos omega t. So this can be written as I is equals to Vm cos omega t by 1 by omega c. Why? Because suppose 1 by omega c, it will be taken into numerator, then it will be reciprocal. Then what will happen? Vm into omega c cos omega t. So I is equals to Vm cos omega t by 1 by omega c. So here also, see, once the current is in cos omega t. So but the voltage is Vm sin omega t. So here the voltage is in sin so I is equals to Vm cos omega t by 1 by omega c. So this is also in terms of cos, but the voltage is in terms of sine. So we have to convert cos into sine. Sine 90 plus theta. So sine 90 plus theta is nothing but cos theta. So then I is equals to Vm sin omega t plus pi by 2. It can be written as omega t plus pi by 2 by 1 by omega c. So here Vm is nothing but maximum voltage and 1 by omega c is nothing but, it can be written as 1 by omega c can be written as xc. Here xc is known as resistance which is offered by the capacitor. Which is offered by the capacitor. So, this 1 by omega c is known as capacitive reactance. Capacitive reactance. So, here 1 by omega c is nothing but capacitive reactance. So, Vm is known as maximum voltage. Maximum voltage. So, this can be written as Vm by Xc. I is equals to Vm by Xc sin omega t plus pi by 2. From this, I is equals to Im sin omega t plus pi by 2. So here the current leads the voltage by pi by 2 radians. Here the current leads the voltage by pi by 2 radians. So here from this Vm by Xc can be written as Vm by Xc can be written as Im. So Im sin omega t plus pi by 2. From this equation, what we have to observe means here omega t plus pi by 2. Here the voltage is Vm sin omega t and the current is sin omega t plus pi by 2. So here the current leads the voltage by pi by 2 radians in that resistor. So whenever the AC voltage is applied to a resistor, so then what will happen? There is no phase change. V is equals to Vm sin omega t and I is equals to Im sin omega t. So there is no phase change. Phase change is 0. Whenever the AC voltage is applied to a inductor, whenever the AC voltage is applied to an inductor, then what will happen? So from that, in that equation, what is voltage? Vm is equals to Vm sin omega t and the current is nothing but Vm by XL. Vm by XL sin omega t minus pi by 2. Vm by XL in that case, Vm by XL is nothing but maximum current. So why? Because this is a resistance. XL is nothing but resistance offered by the inductor. So that's why that can be written as Vm by R. R is nothing but current, maximum current. So from that, in place of Vm by XL can be written as Im. Im sin omega t minus pi by 2 means whenever the AC voltage is applied to an inductor, then the current lags the voltage by pi by 2 radians. From that equation. So, next one is AC voltage is applied to a capacitor. So, whenever the AC voltage is applied to a capacitor, then what will happen? Here, this is the AC voltage. So, V is equals to Vm sin omega t and this is the capacitance. The potential drop across the capacitor. The potential drop across the capacitor is, so from that Q is equals to CV, VC is equals to, here VC is nothing but the voltage drop across the capacitor. VC is equals to Q by C. So here V minus VC is equals to 0. Here the potential drop across the capacitor is VC. Why? Because already I explained in resistor why it will be V minus VC. So why V minus VC is equals to 0. So in place of V, what is that? Vm sin omega t minus VC is equals to 0. Vm sin omega t is equals to VC. Vm sin omega t is equals to, in place of VC, what we have to substitute? Q by C. Cross multiplication. Vm into C sin omega t is equals to Q. Now we have to calculate the current. So how can we get the current? We know the charge. So suppose we have to differentiate with respect to time, then we will get a current. So that's why dq by dt. dq by dt is equals to d by dt of Vmc sin omega t. So here dq by dt is nothing but current. Why? Because the rate of change of charge. So the rate of flow of charge is nothing but current. So that can be written as I. I is equals to Vm. Here Vm into C is constant. So Vm and C are constant. So we have to write in front of that d by dt sin omega t. So Vm into C, what is the d by dt of sin omega t? So differentiate with respect to time. So sin omega t differentiation of sin omega t is nothing but cos omega t. So from that omega t into omega. Suppose if it is an integral, then what will happen means omega is in numerator. Sorry, omega is in denominator, and suppose if it is a derivative, then it will be multiple. So whenever suppose if it is integral, then what will happen? Integral sin omega t is nothing but minus cos omega t from that omega t by omega. That is divisible. Omega is divided by that. So here it is differentiation. So d by dt of sin omega t can be written as cos omega t, and it is multiple omega. So here omega t means, so sin omega t is nothing but d by dt of sin omega t is nothing but omega t, and omega t, what is the derivative of omega t? Omega t is nothing but omega dt by dt get cancelled. So from that it is multiple. So into omega. So Vm omega c cos omega t. So from this equation, Vm omega c cos omega t. So here this can be written as I is equals to Vm cos omega t by 1 by omega c. Why? Because 1 by omega c. Suppose if we take into numerator, then what will happen? C by 1, it will be reciprocal. Omega c into omega c by 1. So from that, it will be Vm omega c into cos omega t. So I is equals to Vm cos omega t by 1 by omega c. We know that here voltage in terms of sine and current is in terms of cos. So we have to convert cos into sine. So sine 90 plus theta is nothing but cos theta. So this can be written as cos theta can be written as 90 plus theta. So 90 plus theta is nothing but omega t plus pi by 2. So here Vm sin omega t plus pi by 2 by omega c, 1 by omega c. So here 1 by omega c is nothing but xc, where xc is known as capacitive reactance. Here the resistance offered, this is a type of resistance which is offered by the capacitor. So that is nothing but xc. So xc can be written as 1 by omega c. So from that Vm by xc sin omega t plus pi by 2. So here xc is nothing but the resistance offered by the capacitor. So it is nothing but resistor. So Vm by V by R is nothing but current. So I is equals to Im sin omega t plus pi by 2. So here the current leads pi by 2. The current leads the voltage by pi by 2 radians. So here the AC voltage is applied to a resistor. There is no phase change. And whenever the AC voltage is applied to an inductor, there is a phase change pi by 2. The current lags the voltage. The current lags the voltage by pi by 2 radians. Whenever the AC voltage is applied to a capacitor, the current leads the voltage by pi by 2 radians. Okay, the next one is phase drive. phasor diagram. So phasor diagram is a rotating vector with respect to origin. So suppose for example, already we know that y is equals to a sin omega t. So where a is amplitude and omega t is nothing but angle. So suppose for example y is equals to 6 sin 30. So then what will happen? Suppose this is a graph. So this is a vector. This is 6 centimeters. Amplitude is 6 centimeters and 6 centimeters. And this is the angle 30. So it is a, suppose the angle is 30, 60, 90, so on etc. Then what will happen? The angle is varies. So that's why phasor diagram is a rotating vector with respect to origin. So for the resistor we know that V is equals to Vm sin omega t and I is equals to Im sin omega t. So here Vm sin omega t, Im sin omega t, there is no phase change. Suppose this is 0 and this is pi by 2 and this is 5 and this is 3 pi by 2 and this is 2 pi. So here these two are, this is current and this is voltage. So these two are overlap each other. So that's why there is no phase difference. So this is here one is positive and another one is negative. So the average current is 0. We know that. So this is pi by 2 and this is pi. This is 3 pi by 2, 2 pi. So for that resistor there is no phase change. Next for inductor, V is equals to Vm sin omega t and I is equals to Im sin omega t minus pi by 2. So minus pi by 2. So here, so see once we have to draw a graph. We have to plot a graph between voltage and current. Then what will happen? So V is equals to Vm sin omega t. So Vm sin omega t is nothing but, suppose for example omega t, theta is 0. So sin 0 0. After that, if that omega t is pi by 2, omega t is pi by 2 is nothing but maximum. So this is the pi by 2 and after that pi means sin 180. Sin 180 is nothing but 0. So this is 0. After that 3 pi by 2. 3 pi by 2 is nothing but sin 270. Sin 270 is nothing but minus 1. So that's why it is a negative. After that 2 pi. 2 pi is nothing but 0. So according to current, I is equals to Im sin omega t minus pi by 2. Suppose for example, here if theta is 0, for example theta is 0, then what will happen? Minus sin 90. Minus sin 90 is nothing but minus 1. Sin 90 is nothing but 1. It will be minus. So that's why the current starts here from the negative. So this is the negative y-axis and this is the positive y-axis. So here this is negative. Suppose for example if the omega t is 90, then what will happen? So then what will happen? 90 minus 90. 90 minus 90 is nothing but 0. 0. So then the current is 0. So it will be starts here, after that 0. Next, if it is 180. If it is 180 means 180 minus 90. 180 minus 90 is nothing but 90. Sin 90 is 1. So this is 1 maximum value. Sin 90 is maximum. After that, after 180, 270. 270 minus pi by 2. 270 minus 90. That is nothing but 180. So sin 180 can be written as sin 180 can be written as sin 90 plus 90. Sin 90 cos 90. Cos 90 is 0. So that's why it will be 0. Like that, here the graph. So this is the maximum value of voltage and is the minimum value of voltage. Is equal to Vm sin omega t. I is equal to Im sin omega t plus pi by 2. So here, see once again, V is equals to Vm sin omega t. So this is 0, this is pi by 2 and this is pi and this is 3 pi by 2 and this is 2 pi. So we know that it is same as all. But what about current? Im sin omega t plus pi by 2. Suppose if it is 0, omega t is 0, then what will happen? 0 plus pi by 2, that is nothing but pi by 2. Sin 90, 1, maximum value. So it will be here, positive axis. After that, suppose 90, omega t is nothing but 90 plus 90, 180. 180 is nothing but sin 180 is 0. So that's why it will be here. After that, 180 plus 90. So 90 plus 90, 180. Sin 180 is 0. After that, what will happen? 180 plus 90. If theta is 180 plus 90, 270. 270 is nothing but minus 1. So it will be negative. It will be negative. So after that, if theta is 270 plus 90, 270 plus 90, 360. 360 is nothing but 0. So that's why here. So these are the phasor diagrams. When what is the voltage varies with current. So here the voltage is Vm sin omega t, Im sin omega t, no phase change. Here we in place of when a AC voltage is applied to an inductor, V is equals to Vm sin omega t, I is equal to Im sin omega t minus pi by 2. Here the current lags the voltage by the pi by 2 radians. Then the phasor diagram is like this. For capacitor, is equals to Vm sin omega t, I is equals to Im sin omega t plus pi by 2. So here the current leads the voltage by pi by 2 radians when the AC voltage is applied to a capacitor. So then the phasor diagram is like this. So these are about the phasor diagrams. Thank you.
Good morning everybody. Wish you a happy and prosperous New Year. This New Year you may enjoy happy things, happy moment. Enjoys will be come in your life and your families. Once again, I wish you a prosperous New Year. Today, I would like to focus my concentration to work out some more problems on partnership. So, the preceding classes, nearly 10 or more problems have been worked out. We did nearly 10 problems. Along with 10 problems, some of the problems we would like to work out because it is a very, very important examination point of view in which nearly 22 marks questions will be arise. 20 marks in the form of partnership admission this year, and 2 marks. One question for 2 marks may be arise in public examination. So that's why partnership chapter is very, very most important. Today, this is the problem exercise. Given below the balance sheet of A and B. Here partners A, one partner, B, one partner. A, one partner, B, one partner. Their profit sharing ratio 2:1. That means A 2/3, B 1/3. Everything, profits will be distributed between A and B by will be distributed between the A and B according to the old profit ratio, old profit sharing ratio, that is 2/3, 1/3. This is the balance sheet of A and B. Balance sheet of A and B. Balance sheet as on balance sheet as on 31st December 2014. 31st December 2014. This is the balance sheet of orders. In the balance sheet, sources of assets, cash in hand 10,000, cash at bank 40,000, sundry debtors 60,000, stock 40,000, plant 1 lakh, buildings 1,50,000. Buildings 1,50,000. These are the sources of assets. These are the sources of liabilities. Bills payable 10,000. Creditors 58,000. Outstanding expenses 2,000. Capitals. A capital 1,80,000. B capital 1,50,000. About it, that is 31st December 2014, they are decided to admit C as a new partner. C is new partner. C is a new partner. So they are decided to admit C as a new partner. So for 1/4 share, for 1/4 share, in future profits, C may be received 1/4 in profit and loss account, 1/4 any profits, 1/4 any accumulated and distributed profits except the extra cost. So they are decided to admit C as a new partner for 1/4 share for the expansion of the business, or some other may be reason. So C may brought 1 lakh as share capital for 1/4 share. Capital of C 1 lakh for 1/4 share capital. Capital of C capital. C will bring rupees 1 lakh for 1/4 share. Then and C brings goodwill as a goodwill 60,000. 1 lakh rupees is the capital. Goodwill rupees 60,000 will be brought by C at the time of admission. So in goodwill amount, half of the amount withdrawn by old partners. Half of the amount. That means 30,000 rupees amount has been withdrawn by old partners according to their old profit sharing ratio, in which 2/3 share 20,000 taken by B A and 30,000 multiplied into 1/3 withdrawn by B, that is 10,000. 10,000. So share of goodwill amount to A 20,000, share of goodwill amount to B 10,000 withdrawn by old partners. So here share profit, half of the goodwill amount withdrawn by old partners, half of the goodwill amount withdrawn by old partners. Now another adjustment, plant to be appreciated by plant is to be appreciated to 1,20,000. So plant cost in balance sheet book value 1 lakh, it was appreciated up to 1,20,000. Nearly 20,000 has been increased in plant. So the value of plant increases from 1 lakh to 1,20,000. Net increase 20,000. Then value of building is appreciated by 10%. Building value 1,50,000. So appreciation of buildings 10%, that is 15,000. 15,000 net increase in building 15,000. Book value 1,50,000 plus appreciation 1,65,000 in new balance sheet. Then stock is found overvaluation by 4,000. 4,000 rupees excess. So it must be reduced. It must be reduced. So now stock value 30, we will exhibit stock value 36 rupees only, 30,000 rupees only. Next, a provision for bad debts and doubtful debts is to be created. 5% on debtors 60,000. 5% provision is to be made on debtors. That means 3,000 rupees uncertainty about 3,000 rupees the form of bad debt. So we must deduct it from debtors. It is lost, so that's why it must be debited to revaluation account. Then creditors were unrecorded to the extent of 1,000. Unrecorded creditors. Now we will try to record. So here creditors value has been raised from 58 to 59. 1,000 rising. So it is a net loss to the business entity. Then these are the problem. From which we would like to design revaluation account, partners cash account, partners capital accounts, and new balance sheet. Okay. First of all, we design revaluation account. The main purpose of designing revaluation account is to find out, to calculate, to assess any profit or loss on revaluation of assets and reassessing the liabilities. So that's why we must design revaluation account. Revaluation account. Revaluation account. Here debit and credit. Account has been divided in two parts, namely debit part, credit part. Debit side particular sum amount, and similarly credit side particular sum amount, and the credit side also particular sum amount, particulars. Amount, particulars amount, particulars, amount. Particulars amount. Okay. So plant used to be appreciated by appreciated to 1,20,000. Book value of plant 1 lakh. Here appreciated value 1,20,000. Nearly 20,000 has been right. So it is net profit. It must be repaid. Revaluation account is a nominal account. All expenses, losses must be recorded debit side. All incomes and profits are recorded credit side. Here profit is nearly 20,000. Exact 20,000. Profit on revaluation of stock of plant 20,000. So it's a profit. It must be recorded credit side of revaluation account. By plant 20,000. Old value 1 lakh. It was raised up to 1,20,000. Raised up to 1,20,000. Similarly, value of building is to be appreciated by 10%. Buildings, by buildings. 15,000. 1,50,000 multiplied 1,50,000 multiplied 10 by 100 is equal to 15,000. value of buildings. Next, stock is found overvaluation by 4,000. To stock, actually cost of stock 36,000. Unfortunately, recorded 40,000. So now, to stock 4,000 depreciated. To stock 4,000 depreciated. Next, provision for bad debts and doubtful debts needs to be created at 5%. Debtors 60,000, on which 5% provision is to be made as bad and doubtful debts. So provision for bad debts to RBD or to debtors. So RBD, reserve bad debts, reserve for bad and doubtful debts. 60,000 multiplied 60,000 multiplied by 5 by 100 is equal 3,000. Is equal 3,000. Then creditors were unrecorded to the extent of 1,000. 1,000 rupees creditors are not recorded. So that's why you must be cut here. To creditors. To creditors. 1,000. 1,000. Then 35,000 credit balance. Revaluation account credit balance 35,000. Carry forward to debit side 35,000. Debit balance 8,000. Credit balance 35,000. Debit balance 8,000. So there is a profit on revaluation. Profit on revaluation 27,000. Profit on revaluation 27,000. It must be distributed among the old partners according to their old profit sharing rate, that is 2 by 3. So 27, 9, Share of A 18,000. Share of B 9,000. 9,000. Total profit 27,000. So total profit, credit balance 35,000, debit balance 8,000, net profit 27,000. It was distributed between A and B. A share 18,000, B share 27 multiplied by 1 by 3 equal 9,000. B share 9,000. So here profit arises on revaluation. It must be transferred to partners' capital account. So here to A capital account, A capital account 18,000 to B capital account 9,000. Now debit balance 35,000, credit balance 35,000. Okay, then we would like to design cash account. Cash account has been changed. Cash account has been changed due to admission of the new partner. He entered and bring 1 lakh as a cash and 60,000 as a goodwill. 1 lakh rupees cash, 60,000 as a goodwill. So cash account has been changed. Cash account. Cash account. Cash account, particular amount. Similarly, particular amount. particulars amount. So cash in hand according to balance sheet book value, cash in hand 10,000. To balance brought down to balance brought down 10,000. Cash in hand according to book value, according to balance sheet, cash in hand 10,000. Now C admitted, C brought it to this 1 lakh as a share capital and a 6,000 as a goodwill. So to C capital account, to C capital account 1 lakh and then to goodwill 60,000. Half of the goodwill amount withdrawn by old partners. Here, half of the amount means 30,000 in which 20,000 taken by A, 10,000 taken by B. So by A capital account withdrawn by 20,000 and by B capital account 10,000, total 30,000. So C brought to be 60,000 as a goodwill in which half of the amount, that is 30,000 withdrawn by old partners, A withdrawn by 20, B withdrawn by 10,000. Now we would like to balance 160, 170, 1,70,000 debit balance. Carry forward to credit side 1,70,000 minus 30,000. Cash in hand 1,40,000 by balance. By balance 1,40,000 carried out. Next, carry forward debit side to balance 1,40,000. Now cash in hand 1,40,000. New cash balance 1,40,000. Changes have been taken place. Old balance 10,000. C brought rupees is 1 lakh is capital and 6,000 is goodwill. Total 170. Goodwill amount 60,000 in which half of the goodwill amount withdrawn by old partners A 20,000, B 10,000. Net balance 1,40,000. This is the new balance of cash in hand. Then we would like to design partners capital account. Partners capital account. Partners capital account. Partners capital accounts. Capital accounts. DR, CR. Partners capital accounts. C, B, A. Particulars. Similarly, particulars A, B and C. Particulars A, B and C. Similarly, particulars partners capital accounts format. You would like to adjust capital accounts according to conditions given by here at the time of admission of the new partner. So, old partners share capital according to balance 1,80,000, 1,60,000 by balance. B by the brought down. A 1,80,000. B 1,50,000. C dash. Now C brought a new partner not by cash. C brought it rupees 1 lakh as a share capital. Then profit on revaluation. A share 18,000, B share 9,000. So by revaluation account, bracketing profits. A share 18,000, B share 9,000. No share to A, C, because he is a new partner. Then goodwill amount, goodwill 30,000 brought out by C. So by goodwill in which share of A share 40,000, B share 20,000, no share to C. So A share amount would be 40,000, in which half of the amount has been withdrawn by old party. Out here, to cash withdrawn by half of the amount 20,000. B 10,000, half of the amount withdrawn by old partners. Half of the amount means 30,000. Total would be around 60,000, in which share of goodwill to A 40,000, B goodwill share 20,000, in which A half of the amount, that is 20,000 withdrawn by A. Here 1 by 2 amount, that is 10,000 withdrawn by B. Now you would like to find out capital account balances. Balance in the capital accounts. C 1 lakh, B 170, 179, 1,79,000. A 220, 230, 238. 2,38,000. Carry forward to debit side. Carry forward to debit side. 2,38,000. A 1,79,000. B 1 lakh. C. So credit balance of A 2,38,000, whereas debit balance of A 20,000. So 2,38,000 minus 20,000 is equal to 2,18,000. To balance. 2,18,000. Similarly, B balance, B capital amount 1,79,000 minus 10,000. 1,69,000. 1,69,000. C capital account 1 lakh. Then carry forward to credit side by balance. Brought down by balance brought down 2,18,000 in A on 2 lakhs 18,000. A balance 2 lakhs 18,000. B capital accounts balance 1 lakh 16,000. C capital account balance 1 lakh. This is the partners capital accounts after adjusted value. After adjusted value, A capital shows 2 lakhs 18,000. B capital account shows 1 lakh 16,000. C capital account shows 1 lakh. 1 lakh. These are the partners capital account. Now we would like to prepare new balance sheet. We would like to prepare new balance sheet after entering prepare new balance sheet. New balance sheet. New balance sheet as on 1/1/2015. 1/1/2015. Next date 1/1/2015. New balance sheet of Farman. New balance sheet as on 1/1/2015. On 1/1/2015. Assets amount assets amount liabilities amount liabilities amount okay. Then we would like to prepare new balance sheet based on old balance sheet. According to old balance sheet, assets are like this, liabilities are like this. According to new balance sheet, some assets may be changes taken place, some liabilities may be changes taken place. Now cash in hand. Cash account has already resigned 1,40,000. Cash in hand. Cash in hand 1,40,000. Cash in hand 1,40,000. Next, cash at bank, no changes. Cash at bank also 40,000. Cash at bank 40,000. Then sundry debitors 60,000 minus provision is to be made 5%. Provision is to be made already 3,000. So debitors 60,000 inner column minus RBD 5%, that is RBD 3,000 minus 3,000, that is 57,000. 60,000 minus 3,000 is equal to 57,000. Next, stock value excess 4,000 అన్నాడు. Stock inner column 40,000 minus excess value 4,000. net value of stock 36,000. 36,000. Next, plant. Plant and Mr. Land 1 lakh. It was raised up to 1,20,000. So 20,000 rupees has been raised. Plant 1 lakh plus appreciation 20,000. Total 1,20,000 outer column. Body column no Akshay Plant 1 lakh. Period of appreciation 20,000 is equal to 1,20,000. Next, buildings. Buildings inner column 1,50,000 plus appreciation 10%. At 10% that is 15,000. Total 1,65,000. Total 1,65,000. Total 1,65,000. Total 1,65,000. Total 1,65,000. Then libraries, bills payable 10,000. Bills payable 10,000. Creditors 58,000. Creditors 58,000. Next, outstanding expenses 2,000. Creditors for unrecorded, plus 100 plus creditors 58,000 plus unrecorded creditors 1,000. Total 59,000. Creditors book value 15,000. In adjustment, creditors were unrecorded to the extent of rupees 1,000. So 58,000 plus 1,000 is equal to 59,000 will be recorded in the liability side of balance sheet. Then capitals. Capital accounts of products has been designed. A capital 2,18,000. A capital 2,18,000. B capital 1,69,000. C capital 1 lakh. C capital 1 lakh. All adjustments are over. Plant appreciation has been recorded. And buildings also recorded. Stock, value of stock also recorded. Provision for bad debts also recorded. Creditors were also recorded. Now we would like to total the balance. Balance sheet total. We would like to find out balance sheet total. Five plus 6, 11. 11 plus 7, 18. 1 plus 6, 7. 7 plus 2, 9. 9 plus 3, 12. 12 plus 5, 17. 17 plus 4, 21. 21 plus 4, 21, 25. 25. 25. 2 plus 3 plus 1, 4 plus 1, 5. 2, 3, 4, 5. 5 lakhs 58,000. 5 lakhs 58,000. 5 lakhs 58,000. Okay? 5 lakhs 58,000. 5 lakhs 58,000. Here, liabilities total 9 plus 8, 17, 17, 19, 19 plus ఒక 9, 28, 28, 2, 8, 8, 9, 9, 14, 15, 15, 1, 2, 3, 4, 5,58,000. Liabilities total 5,58,000. Assets total 5,58,000. So once again, cash in hand 1,40,000. Cash at bank 40,000. Debitors 60,000 minus half 25%, 3,000 is equal to 57,000. Stock excess value of stock 40,000 minus 4,000 is equal to 36,000. Plant 1 lakh plus appreciation 20,000. Total 1,20,000. Buildings 1,50,000 plus appreciation 50,000. Total 1,65,000. 1,65,000. Total of assets. Total value of assets. Next, liabilities. Bills payable 10,000. Bills payable 10,000. Creditors 18,000 plus 58,000 plus unrecorded 58,000 plus unrecorded 1,000 equal to 59,000. Outstanding expenses 2,000. A capital 2,18,000. B capital 1,69,000. C capital 1 lakh. Total 5,58,000. This is the new balance sheet of firm. So if you have any doubt, I would like to clarify tomorrow. Okay? All the best. Thank you very much for listening.